streaming your normal 3D graphics. This is extreme streaming of extreme 3D graphics. This is ridiculous levels of 3D graphics. This, first of all, come on. This is Michael. Michael is one of the pioneers in the computer industry. He looks like one of the pioneers. This is the famous Michael Kaplan. And he's going to demonstrate to us this is the first showing of a new technology he created called iray. And it's going to be part of a web platform, cloud computing platform called Reality Server. So Michael, first of all, I think this is Michael's laptop.
Right.
And this laptop is connected to web. There is a Reality Server somewhere on the cloud somewhere with how many GPUs?
15.
With 15 GPUs in this cluster. And what I'm looking at is looks like a photograph.
Right.
It looks like a photograph. So tell us, what are we looking at?
So this is the type of image that an architect would render in high-quality rendering software like Reality Server or Mental Ray software that they already have. This kind of image, which they send to their clients to show what a synthetic environment would actually look like, could take, minimally on a large GPU, a multi-core CPU, would probably take at least a half an hour, probably more like 2 or 3 hours to produce an image of this realism for each image. And so animations, of course, are subsequently longer.
Now, Michael, what makes this image so hard to create? First of all, it looks just exactly like the photograph.
Well, that's what makes it hard to create. The key here is that we're doing real physical light simulations, so we're not doing a lot of approximations, a lot of tricks to try and make shaders look like reality. What we're doing is we're simulating the flow of the light on real materials using real model light sources. And so all those little subtle effects that people who are used to this sort of thing look for, the really subtle shadows around the columns on the ceiling, the multiple light effects of light. All the light you see here is indirect. It's coming in through the windows and between the shades, bouncing around, but bouncing around millions and millions of times for every sample. Every pixel that you see has millions and millions of samples in it to create this highly realistic image.
Now, this entire room is lit through indirect light.
Yeah, this is all coming in through the windows. And so this is the kind of thing that an architect would model there. This is a real, this is a synthetic image of something that was modeled for a real architect in Berlin, Germany, and it's a 3 million polygon scene of a real office complex.
Now, Michael, could you show us a few other scenes?
Yeah.
Show us interacting with this thing.
Well, the key here is this looks like a final image, but I can just turn my head. Wow. And what I'm doing here is I'm telling the cluster with 15 GPUs to restart the image from scratch. So what you're seeing is recalculating a photorealistic image totally from scratch.
Now, my first observation is you have the world's most powerful laptop.
This laptop, we were going to show it on a netbook, but you could also do it. This laptop now, to give you an example, what you're seeing is doing is approximately 300 million sample calculations per second to produce this image.
So this is running basically on a web browser. You have this amazingly complicated scene here, and it's every single time you move it, it's recomputing it back in the cloud and then streaming it back to you.
That's right. And to give you an example, let's say we want to change the time of day to where the light's coming in more directly. All I like to do is throw a switch, and I model the sun differently. All of a sudden, I see an entirely different lighting situation. Again, completely real time, completely interactive. Now you said you were talking about transformative experiences. Right now, what the architect does, or the visualizer, is they take their scene, they make a couple of nice images to send to the customer, or else they make a movie. The movie takes maybe days to create this movie because it takes so long. Then they send this to the client. The client says, well, I really want to see different lighting situation. I want to see different configuration. This completely changes that workflow.
Now, for the audience that are looking at this, to you, I think that I would imagine you're looking at this and it looks photorealistic to you. However, if you look at all of the subtleties that makes it look photorealistic to you, it is just really, really impressive what iray is doing. The subtle soft shadows that are around the columns, the reflections of the wood floor that's not completely reflective, is kind of looks like matte.
Yeah,
And
semi-glossy
semi-glossy.
is extremely hard to simulate, right?
Now, why is semi-glossy so hard to simulate?
Well, because you're not just getting the light reflecting on the wood floor, which is semi-glossy, and back to you, but the light reflecting off of that floor on the glossy part is now going to reflect off of other things in the scene. So you're seeing 4 or 5 up to 10, maybe essentially 20 levels of indirection of the light bouncing around from surfaces that are very hard to simulate.
Now, the way the reflectivity and the behavior of a particular surface as it reacts with light differs from material to material.
That's right. So we have a very rich material model, which can be programmed to simulate almost all of the materials that are commonly used by people doing visualization in all the standard packages like Autodesk 3ds Max, Maya, Softimage, Dassault, parametric technologies. For all use our current technology, we have taken the materials that visualizers use and we've mapped them directly into iray. So they don't have to change their workflow at all. They just have to say, use iray, and the difference here is they don't have to understand how the render works. So for people who work with high quality rendering right now, you have to really be an expert to make this work properly. To get an image like that, with the subtle effects, you might not even be able to get it, and if you did, you'd be a master of rendering. I just pushed a button. I don't even have to use these tools.
Yeah, this was a really good tool. You can close the windows.
Right. Well, I can do that, actually. Let's close the blinds and see what the lighting looks like with the blinds half open. Again, I want to emphasize nothing is pre.
That's just amazing.
Here. And then if we close the blinds completely, you'll see just the light that's leaking in around the edges of the blinds, plus some light coming directly through the blinds. Again, completely accurate.
Now, can we change the time of day now to
Sure.
say nighttime? I can just sit here and dink with this all day.
It's a lot of fun to play with. If I go back to this view, for example, and change the time of day to night, you'll see another feature of iray, which is the accurate simulation of physically correct lighting. So you see there's about 60 or 70 lights in the ceiling, and those lights are being accurately simulated in terms of the area of the lights and how they project. We even do IES profile lighting. And so what you'll see is essentially what this scene would actually look like, except instead of waiting an hour or a couple of hours, we just saw it.
Wow. I mean, you look at the whiteboard, even underneath the whiteboard where that soft shadow is, the way the shadow looks like it's bleeding down from the light above it, it's just really beautiful.
Another thing we can do is simulate different configurations. So let's say the client had an empty spot in the office right there. We want to see what would happen if they put another workstation in. So we just say, for example, turn on another table. It throws another table in, and it completely starts simulating from scratch. And that's 300 million, 600 million, 900 million, 1.2 billion, 1.5 billion. You just saw approximately 2 billion sample calculations.
That's unbelievable.
To make that image.
Michael, this is